The last two videos that I posted about measures of center and measures of spread were videos that I recorded last decade for a GRE course, so they're not specific to this class. I wanted to jump in at this point and make some more class-specific comments and material. So this lecture will be called More About Summary Statistics. It still covers sections 3.1 and 3.2 in your book. And our main topics today will include notation, additional measures of spread, calculations, and approximations. Okay, starting with notation. Let's take a look at this table. The notation refers to different symbols that we use for different statistics and parameters. I'd have to say this is pretty important. I really need you to be conscious of these symbols because we're going to see a lot of them in this course for contexts that are similar but not identical. And it's going to be really important that you're able to always be clear in your mind about exactly which symbol to use when. This topic is going to be with us for the rest of the course. So for example, when we're talking about means, a mean is abbreviated with the symbol X bar when it is the mean of a sample. That's called a statistic. Remember that statistics measure samples. But if we are talking about the mean of a whole population, that's called a parameter, and that has a different symbol. It has this funny looking Greek symbol, which is called mu. That's right, it's a half m, half u, mu. Okay. Standard deviation, if we're measuring the standard deviation of a sample, we abbreviate that standard deviation as lowercase s. But for the standard deviation of a population, we use Greek letter lowercase sigma, which is basically the Greek version of an s. That's all we need to know about notation for now. There are going to be, like I said, a lot of these symbols coming in the next few weeks. But just to give you a flavor of it, this is the kind of notation that we'll have to keep track of. Okay, additional measures of spread. So in the previous lecture, I introduced the standard deviation and the range, which are probably the most commonly used measures of spread, and they're the ones that are tested on the GRE. That's why they were in that lecture. Your course is also going to test you on three other measures of spread, two of which we discussed now, and one is coming in the next lecture. So the ones that we're discussing today are called the variance and the coefficient of variation. I actually said a little bit more about those in this outline here. So the definition of variance, which we can abbreviate with a V, is literally the standard deviation squared. So whatever the standard deviation is, you just square that number, and that result is called the variance. So the symbol for it is also s squared, and that's literally what it means. The coefficient of variation, CV, is defined as the standard deviation divided by the mean. And if you think about it, that's really useful because if we know that things vary by like 6 inches, we don't know if that is like 50% of their length or 1% of their length. So when we divide it by the mean, that gives us a fraction, which we can convert to a percent. These are rarely used, but I think they're actually really useful. So let's take a look at a couple of examples. Suppose that the lengths of grains of rice and manufactured bolts both have a standard deviation of 0.6 millimeters. Question 1, calculate the variance in the lengths of grains of rice. And of course, this would be the same for the bolts. So we learned that the variance is the standard deviation squared. So that would just literally be 0.6 millimeters times another 0.6 millimeters. And this would give you 0.36. And the units for that would be millimeters times millimeters, or millimeters squared, square millimeters. So most measures of center or spread have the same unit as x. So if x is inches, or in this case millimeters, if x is millimeters, then the mean or standard deviation or median of these grains of rice will all be measured in millimeters. The variance is an exception to that. It has this funny unit of square millimeters. Okay, next question. Grains of rice have a mean length of 2.4 millimeters, whereas manufactured bolts have a mean length of 24 millimeters. They're 10 times longer. Calculate the coefficient of variation for each. Okay, so remember that again, the coefficient of variation is given with this formula here. I'll copy it onto this other page. Standard deviation divided by mean. So if we perform that calculation for the grains of rice, I guess I'll just copy it again. That standard deviation is, of course, 0.6. And the mean is given for grains of rice in this problem as 2.4. And when you divide that, it still has a bar over it, sorry. When you divide that out, it gives you 1/4 or 25%. So that tells you that the grains of rice are kind of varying plus or minus 25% of their own length, right? So that's kind of a lot of variation, which makes sense because they're living things and they grow in different circumstances. If we repeat this calculation for the manufactured bolts, the coefficient of variation, the standard deviation is 0.6 again, but in this case, the mean is 10 times longer. It's 24 millimeters. And therefore, the coefficient of variation will be 10 times smaller. It will be 1/40th, or 2.5%. So these bolts only vary within plus or minus 2.5% of their own length. Well, that's good to know because bolts are supposed to be pretty consistent. In fact, I'll bet you in real life they're probably more consistent than that. But that example goes to show that even though the rice and the bolts have the same standard deviation, they both vary basically by plus or minus 0.6 millimeters. That is a much larger fraction of what the grain of rice actually is, whereas the bolts are much more consistent relative to their own length. Let me see what other notes I had to say about these additional measures of spread. I guess that's about it. Okay, calculations. So the previous lecture that you just watched about the measures of center showed you how to calculate those by hand, basically. It skipped over the calculations for the standard deviation. And that's something that you'll rarely have to calculate by hand. In this class, you will be asked to calculate the standard deviation, but you won't do it by hand. You're going to do it with StatCrunch, of course. So I want to open up StatCrunch to show you, first of all, how you can access data from the homework, and then how you can work with it. All right, so over here I have homework set 2 open. And here's a list of numbers. This happens to be question 19. If you look really carefully, you see this blue spreadsheet icon. And that indicates that if you click on it, you can open this data in StatCrunch. I might need to pause this for a second. All right, so when I opened that homework problem, it opened StatCrunch for me, and it had those 10 numbers in this list. Whenever you open your homework, of course, it's going to generate a new list of numbers, so your numbers will be different from mine. But we can calculate a whole bunch of statistics on these by going to Stat, Summary Stats. And we're going to select columns because we are going to be calculating the statistics for a particular column of numbers there, variable 1. All right, so I have to highlight variable 1. Now, here's basically your menu of calculations that you can perform. There's just quite a lot of them. StatCrunch can give you n. Remember, that means the number of items in the list. The mean. I'm going to go ahead and highlight the ones that we're going to use this week. And to select more than one, you press Control on your keyboard while you're left clicking. Mean, variance, standard deviation. We won't need standard error this week. Median, range. I'm going to skip over min and max. Quartiles, we'll do those later. Sum, IQR, we'll do that later. And coefficient of variation. Okay, so I'm going to select all of those. By the way, while I'm here, I'll quickly draw your attention to these items, the unadjusted variance and the unadjusted standard deviation. StatCrunch uses that term unadjusted to mean population. So these would normally be called the population standard deviation and the population variance. The default up here, the regular old variance and standard deviation are by default for the sample. In your homework in this class, you should always choose these first items up here, the sample versions, unless your homework expressly tells you to use a population or adjusted standard deviation. Okay, so I've selected a whole bunch of them. What I like to do, by the way, when I calculate these numbers, is I like to store them in the data table. And what that means is that when we close this box, this pop-up, we'll actually see all of our results in the original table. So when we click Compute, here they are. It just gives you a little confirmatory message here, which I can close. But over here, all those statistics were inserted into the table. So the mean was this number, the variance, the standard deviation, median, range, coefficient of variation. Very easy. All right, today's next topic is about approximations, and I only have 2 minutes left, so I don't have time for this on this video. So I'll close this clip and then we'll address this in the next video.